When we talk about electronics, we often forget that in addition to resistor and capacitor, there is another component, inductor. In this video, we will see why they are so important and when they are used. Inductors often are compared with capacitors. This is because their behavior is similar. Indeed, capacitors, as we have seen, store electrical energy in an electric field. Inductors instead store energy in a magnetic field when the current flows. There are other differences between capacitors and inductors, and if you are curious, you found them in this section of my app. Link for download in the description. It's important to note that inductors often are called in different ways, based on their use. Typically, we can also call them coil. In fact, inductor consists of an insulated wire wound into a coil around a core. If inductor is designed to block alternating current, allowing direct current to pass, then we can call it choke. Inductors are also employed in electrical transmission systems, where they are used to limit switching currents and fault currents. In this field, they are commonly referred to as reactors. You may have noticed that this kind of components are very bulky, and for this reason it's not very easy to find them in microelectronics field. In that case, engineers try to simulate the behavior of an inductor with other solutions. To measure the magnitude of an inductor, we use inductance, and its measure unit is expressed in Henry. As capacitor, we will often use submultiples of Henry, such as picohenry or microhenry. In the case of a cylindrical inductor with area as a core, we can use this formula to calculate the inductance, where μ is the magnetic permittivity of the core, n the number of the coils, a the area of the section of the core, and l its length. So we could think that it's very easy to create a DIY inductor, but unfortunately it's not so easy. In fact, there are many factors that could generate big errors at the end of the process. For example, the diameter of the wire is not constant, the distance between every spiral, and so on. For this reason, when we use a commercial coil, I always suggest to check their inductance, also because often it's not written on the component. To measure an inductance, we need LCR meter, or if you feel pro, it's also possible with an oscilloscope. If you want a specific video to do that, the comment section is perfect to let me know. Okay, so how can we recognize an inductor in a schematic? As always, there are different standards to represent them, but most used is definitely the US one. As regard the real component, they are usually used like a coil, but if you're a maker, I suggest to buy this kind of inductors. First of all, because it's very easy to know their value. Indeed, as you can see, there are some colored bands. This color code is the same of resistor, so it's very handy. The range value also in this case follow the E standard, and again you can check every value for every standards in my app. To conclude, we can say that differently from the capacitor, inductor doesn't explode, but this doesn't mean that there are no dangers. If we apply a big current to them, the temperature starts to increase, and if we don't handle it, the inductor starts to melt, but some engineers thought to exploiting this behavior. In fact, sometimes we can use inductor to melt other materials, like metal. Now it's time to go to the lab. As resistors and capacitors, we can connect 2 or more inductors in series or in parallel, but as always there will be a dedicated video. It's interesting instead to have a look to the application of inductors. The main use is certainly as an input of a power supply, to avoid for instance that the initial spike of current could damage the circuit. This is a further analogy with capacitors. In fact, while the latter are great filter for direct current, the inductors are perfect to filter alternative current. We can also find them in every transformer that indeed consists in a magnetic core with 2 coils and permits to step down or step up an input voltage or a current. Recently, they are also used in another type of power supply, called switch power supply. This type of power supply are more efficient than the classical one, but it's not perfect to power applications that work with high frequencies. Another use could be as a filter or in a radio applications, where in particular they are employed to select a specific frequency to listen to our favorite podcast. Recently, inductors are also used to charge devices. Indeed, any wireless phone charger easily consists in a coil that delivers power through electromagnetic induction. To conclude, they are employed to make relays, where the magnetic field generated by the coil is used to attract a metal plate and close the contact. So that's all for this video. If you like it, let me know lighting up the like button, sharing and subscribing. If you have questions, please don't hesitate to comment. Don't forget to always expand your knowledge and see you in the next video.